Hello, welcome to everyone. In this video, this is our lecture number 8 for theoretical of electronics. Previous lecture we discussed about the basic fundamental theory of electrics, that is the Norton theorem, Thevenin theorem, superposition theorem, etc. etc. After that we discussed the diode, and the last two lectures consist the BJT, that is the bipolar junction transistor. Okay. In this part, we want to discuss, that is the transport of two-port electron H parameter equivalent circuit, etc. That is the H parameter we want to discuss here. If you want to watch the previous lecture, you can go through the description box, and there are separate playlists for different part of each related. You can go through this channel. You can get the different playlist for different part of the physics theoretical part and some problem solution part. Okay. You can see this is the syllabus for University of Calcutta BSc fourth semester electronics part. This portion, that is the circuit and network, was discussed in lecture number 1, and this is diode and application consists lecture number 2 to lecture number 5, and last two lecture, that is lecture number 6 is consist here, lecture number 7 which consists to the biasing part, and this part we want to discuss in lecture number 8. I think clear the throughout the route of this lecture series. And the upcoming lecture we want to discuss the FET, regulated power supply, amplifiers, and the feedback amplifier and op amp. This we want to discuss in the upcoming session. So and the multivibrator and oscillator. So let's start today's discussion. Now think about this thing. That is the transistor. This, this can be in the common emitter circuit, or in the common base configuration, or in the common collector configuration. You know about these things. These are already discussed. That is CE mode, CB mode, CC mode. Okay. This is current amplification. This is voltage amplification. This is the power amplification, and these three mode actually are consist. And in the last section you know about the stability factor, the how the transistor is stabilized, stability factor, and the q point, about the q point, about the q point. Okay, so the stability factor, the q point. These two are discussed in the last session. Okay, so after getting the q point, you can replace this transistor as a black box. We do not know about the within the transistor how this transistor is effective. We did not know. We just consider this as a black bar. We don't know about within this how the transistor in which. We know about the fourth term, that is the input term, that is input voltage. V1 is the input voltage, V1 is the input voltage, and I1 is the input current. And similarly, the V2 is the output voltage, and I2 is the output current. So there are four variable to input current, output current, input voltage, output voltage. Among these four variable, we take two independent and two dependent. Two independent variable, we take the input current, output voltage. So input current and output voltage taken as the independent parameter, and the rest two are, that is the output current and the input voltage, taken as dependent parameter. So you can easily write down this input voltage and input current in terms of other two dependent variable. So the dependent variable is input current, output voltage. So input current and this output voltage, taken this as a constant, H11, H12. Similarly, for output current can be written in terms of input current, output voltage. So input current, this is output voltage with this constant. Okay, so how will we get the H11? H11 is nothing but the V1 by I1 when V2 is 0. When V2 is 0, you will be get V1 by I1. Okay, V2 is 0 means, this is a short circuited, there is no voltage applied. When the output is short circuited, you will be get this V1 by I1. And the V1 by I1, that is the input voltage by input current, this must be input impedance. Voltage by current is the impedance. So this can be written as input impedance with the output port short circuited. This is output port short circuited for AC. because you know for the biasing you will apply the DC voltage, but for AC we just note about where the application occur or not. Okay, so the H11 is nothing but HI. Why this is HI? This is for input I comes from input. So this is input impedance. Impedance. Why impedance? This is voltage by current. That's why this is impedance. And V20 means the output is short circuited. So I think clear about the constant H11. What about H12? H12 can be find out V1 by V2 when I1 equals to 0. When I1 equals to 0, this V1 by V2 is H12, and H12 you can see this V1 by V2 input voltage by output voltage, that can be say as the reverse voltage gain. Reverse voltage gain, because voltage gain is V2 by V1. V2 by V1 is the voltage gain. So V2 by V1 is voltage gain. So V1 by V2 is nothing but reverse voltage gain or reverse voltage amplification. And I1 is 0. I1 is when 0, this is open circuit. When this is open circuit, the current will be 0. So I1 is 0 means the input is open circuit. So I think clear why this is open circuit, I1 is 0. Why this is R? Because reverse. And why this is voltage amplification? This is V1 by V2. Actually V2 by V1 is the voltage amplification. Reverse is, that's why reverse voltage amplification. Next one is H21. H21 is nothing but the I2 by I1 when V2 is 0. I2 by I1. I2 by I1 means the current gain, and this is forward because this is output by input. So this is forward current gain when V2 is 0. V2 0 means this is the short circuited. When this output is short circuited, the forward current gain is denoted as H21. So this is all about H21, and since this is a forward, that's why we written here the HA. Okay, now next is the H22. What is about H22? H22 is nothing but I2 by V2. I2 by V2 when I1 is 0. I1 0 means open circuited, and I2 by V2, you know the voltage by current is the impedance, and the reverse of this impedance is the admittance. So this is admittance. So why this is called hybrid parameter? H means hybrid. Why this is called hybrid parameter? If you just know about this H means hybrid. Why this is called hybrid parameter? Hybrid parameter, because you can see here the all the H, that is HI, HR, HF, HO, the four are the different parameter. One is impedance, another one is voltage gain, then the current gain, then the admittance. These four are the different quantity in the physics. That's why this is called hybrid. Hybrid means there is a mixture of different things, because these are the different parameter, different types of parameter. That's why this is called hybrid parameter. And all these HI means input impedance, HR means reverse voltage amplification, HF is the forward current gain, HO is the output admittance. So these are the four the hybrid parameter. Clear? Next, what is the advantage of the using the hybrid parameter? What are the advantage? At the audio frequency, the hybrid parameter are real. The hybrid parameter can readily measure. They can also determine from the transistor static characteristic curve. That means from the static characteristic curve of transistor, that is the DC voltage curve. We just using this DC voltage curve, we can find out the hybrid parameter, which is useful in the AC circuit also. They offer simply mathematical expression for the performance of quantity like current, voltage, power gain, input, output impedance, etc. So using this hybrid parameter, you can easily find out this voltage gain, power gain, current gain, input impedance, output impedance. We can easily find out using this hybrid parameter. We will be see the example of that one also. And next thing is the H parameter are convenient to use the circuit analysis and design. So using this H parameter, we can easily the analyze the circuit. Okay, a set of hybrid parameter for a transistor is usually specified for a transistor manufacturer. So hybrid parameter actually specified by the transistor by the transistor manufacturer, and using this hybrid parameter we can get the different value of this transistor also. How? You can check this thing. So the equivalent circuit of hybrid parameter, you know the H11 which is the impedance, H12 is the voltage gain, reverse voltage gain, H21 is the forward current gain, H122 is the admittance. Okay, so you can see if you take the common this is the common emitter circuit. So VB, the voltage of base, will be the input voltage. Current voltage, base current is the input current, collector current is the output current, and the collector voltage is the output voltage. So these are the input current, input voltage, output current, output voltage. So taken the input current and output voltage as the independent, so the dependent will be the input voltage and output current. So delta VB is nothing but the partial derivative of this thing plus this one, just the mathematical expression we can write down. So VB is nothing but HIE. HIE, why this is HIE? Because this is the input impedance and E for common emitter configuration. So this is HIE and this is HRE. This is the reverse voltage gain. This is the reverse voltage gain because this is the input by output voltage. That's why this is reverse voltage gain with VC, and IC which is HFE IB plus these things. This is HFE because this is the forward current gain, and E for emitter, and this is the admittance, output admittance. So this one. So from here you can just write down in terms of change in voltage of the H parameter. Okay, and this can be calculated from this output characteristics. You know, this is the IC and this VC. If you take the change del IC2 minus IC1, and this is IB2 minus IB1. So their change will gives you the small single beta. So this is nothing but the beta value. You know, in the transistor, beta is IC by IB, so their change will be small signal. IC by IB is the capital beta, and this is the this beta, and this is the beta prime. This is the DC part, and when change, this is the AC part. Now know just about this conductance. This is del IC by del VB is nothing but HFE by HIE, that is the conductance. Next thing is the H parameter different mode. Actually, this is the relation between the H parameter with the mode of CE, common emitter mode with the common base, and this is in terms of common emitter with the common collector. We just derive this relation using this parameter. You can see this is a input voltage, this is the output voltage, IC in the output current, input current, etc. So from KCL you can write down these three are inward, so their sum will be 0, and VC is nothing but the addition of these two voltage. Okay, so the H equivalent H parameter equation will be like that. VBE, that is the VBE is nothing but HIE plus IB, HRE plus VC. This is the input voltage. So this is HIE plus HRE plus A. So just HFE plus into this thing. So this is can be write down here from this relation, a basic relation. From this basic relation we can write down these two relation. Okay, if you put the value of you just put the value of IB. IB is nothing but IE plus IC, and VC nothing but VB plus VCB. And from here also you put these two things, and taking the separate out VBE, and then taking separate out IC also. So after the separate out these things and calculating, finally you will be get this value of IC equals to like that. If you neglecting this thing HRE and HE, so finally you will be get this value of IC here, that is the current of this collector. Now this equation of CB, if you take in this CB configuration, common base configuration, you can write the output current is the HFBIE plus HOB CB, B for base, and HF is the forward current gain, and HO is the output admittance. Okay, so this is the that one. So finally you will be get the, if you compare these two things, that is IC here and also IC here, if you compare this thing, you can easily find out the relation between the base configuration with the emitter configuration. So with the help of the any configuration, you can easily find out this hybrid parameter value in the others configuration also. Okay, and VBE into 1 minus HRE equals to this one, elementing IC into in 1, that is 2 in 1, these two relation actually. If you elementing these things, you can easily find out, and finally you obtain the HIB and HRB like that. So these are actually the interrelation between the hybrid parameter in different mode. Now comes in to find out the current gain, voltage gain in that is the input impedance, output impedance using the hybrid parameter. Using the hybrid parameter, we can find out this thing. So the current gain, AI equals to IL by II, that is the current gain is the output current by input current, and IL is nothing but minus of I2 because this is in the inward, IL is the right here, so IL is nothing but like that. So this current gain is this IL by II, so this is I2 by I. So KCL in the output, the KCL in the output, if you use the I2 is nothing but the added up of these two current. So this one HF I1 and this is the H0 V2. H0 V2. Actually the current is voltage by resistance, and this resistance, this is actually admittance. You know this is 1 by H naught. This is 1 by H naught. So 1 by H naught, that's why this is H naught is the admittance. Okay, 1 by H naught is the resistance H naught, HO actually, output admittance. Clear? So that's why this is current, this is current. So added are these two current, it will get I2. So from here it will be I2 equals to this thing, because V2 equals to nothing but minus I2 RL V2 R2 RL. This is RL, R2 means RL. This is actually RL. This is actually RL. Okay. So I2 R2 or ILRL, okay, no problem. So you will be get the taking this I2 in the common, and so I2 by I1 equals to like that. So this is the gain minus I2 by I1. So this is the current gain minus HFE by HF by 1 plus HORL. So this depends on load resistance. So current gain in the circuit depends on the load resistance. Next thing is the input resistance. Input resistance is nothing but input voltage by input current. What is the input voltage? Input voltage is nothing but the voltage drop across here, that is H1 I1, and the voltage drop across HR V2. So you'll be get these things and dividing it. So this is V2 by R1. V2 is nothing but I2 by RL. So this is like that, and I2 by I1 that is the current gain. Putting the value of current gain just previously obtained here. So putting this value, you'll be get this thing. So this is the internal resistance. So this is the internal resistance Ri. Okay. Next thing is the voltage gain. Voltage gain is nothing but output voltage by input voltage, V2 by V1. V2 is nothing but minus R2 by R1, and this thing, and V1 equal to I1 Ri. So after getting this thing, put this value of AI. AI is the current gain, and putting the value of Ri, the input resistance. After putting this thing, you will be get this calculation, you will be get these things, and this is the voltage gain. AB is the voltage gain, where this is the delta is the is the HI H0 minus HF HR. Okay. Next thing is the output resistance. Output resistance is nothing but output voltage by current, V2 by I1. So this is H naught minus HF HR by RG plus HI. You know, in this circuit, you can see in this circuit RG plus RI, total voltage into current, that is the total voltage drop, plus HRRV, must be 0 because this voltage is 0. So finally I1 equals to like that, and I2 equals to nothing but this to H naught V2. You know, this is 1 by H naught admittance. This is 1 by H naught. In the previously, this is 1 by H naught. Okay, this is 1 by H naught. That's right. Okay, 1 by H naught, because H naught is the admittance, so this is 1 by H naught. So I2 is nothing but H naught V2 plus HF I1, and put this value of I1 equals to like that, and putting taking the common, and so this will be the value of R0. So output resistance, this is nothing but the output resistance. And next thing is the power gain. Power is nothing but output voltage by input voltage. So this is AV VI. If you put this value of AV and AI, that is the voltage gain and that is the current gain. So power gain is nothing but production of the voltage gain in the current gain. So after putting these two value, you can easily find out these things. Okay, so I think clear about all the things about the hybrid parameter. We need to solve some mathematical problem also. So if there is any doubt in this portion, you must comment in the comment box. This is all about me. This is my contact detail. You can connect with me with this Telegram channel. This is my online platform, and this is my YouTube channel details. Go to this channel. You will get different physics related video with some mathematics also. Like this session, if you learn something from this session, share this video to your friends, and that he or she also get benefit from this video. Subscribe this channel if you're new in this channel. Those already subscribed, thanks for subscribing. Press the bell icon to get notification of upcoming videos. So take care. We'll meet in the next video as soon as possible. Thank you.